So I want to talk about something that we all have to deal with every single day of our work, and that is complexity. But before we get started with that, let me talk a little bit about just things that I've been doing. Well, when I was a child, I used to tell a lot of scary stories. Now I'm grown up, I just talk about programming, and that is even more scarier. And one of the things people often ask me is, you know, you program in so many different languages. I program in about 15 different languages. I just love programming languages. And people often ask me, what's your favorite programming language? But more important, they ask me, what is the language you hate the most? And I want to say that I actually don't have really a love or hate for languages, but I'll tell you what I really, really hate and probably dislike the most. And that is complexity. I work with a lot of different clients around the world. And when I go to companies, what I find them is oftentimes getting tangled up in complexity, and they're really struggling hard to get out of it. And if you ask me what do I do for a living, I'll say that these days I spend most of my time removing code rather than adding code. I would go to client site, I would work on projects, and when I leave, they often end up having less code than when I walked in, because I find that people are just getting tangled up with complexity and becomes really hard to deal with. So that's what I want to talk about today is how can we make our lives simpler, our lives easier by dealing with complexity that we have to fight every single day. Well, you can't go to a company today and talk about development without talking about agility. And we all want to be agile. And agile seems to be the buzzword that we keep constantly hearing from companies. Well, the reason for that is, of course, as Heraclitus said, the only constant is change. We keep seeing change every single day in our business, in our environment, in our development strategy. Just about everything around us keeps changing. So when it comes to these change, how do we really cope up with change? Well, at least in concept, that's exactly what agile development is all about. So agility is, so what is agile development? And I want to emphasize, we are really heading in the wrong direction a lot of times because we tend to really take ideas and put ceremony around it. And then we tend to really make things complex and we don't get results out of it. When I go to companies these days, one of the things I hear people tell me is, they're so happy to come and tell me I'm a Scrum Master. I always say I'm really sorry. Why do we need to have these kinds of titles? Why do we need to have these kinds of positions? We tend to really put things around things we create, and then ceremony, and then we are trying to really fight it. So when it comes to agility, I would say the real essence of agility is the ability to adapt to change. And I would say probably one of my most unpopular tweet, I would call it that way, the one that got retweeted the most, to my embarrassment, is this tweet. When I said that I've not set the wedding date, I've set the wedding date, I've not asked her out yet. This is how software projects are managed. And this is so true in what we do, isn't it? How many times I worked on projects where the deadline has been set, the scope has been set, and then they tell you we are agile. And I always ask them, what is there left to be agile when all this has been set already? So the question really to ask is, what really makes it really hard for us to deliver our results, deliver our projects? And a lot of things really make it really hard, but one of them I would argue is the complexities that we get tangled up into. So when it comes to complexity, how do we really deal with it? Well, it turns out complexity makes it really hard to adapt to change. And so we want to really be able to adapt to change. That's one of the things about agility is, how can we easily adapt to change around us? How can we really get better at it? And the question and answer to that is, we want to really remove things that will prevent us from being agile. And complexity is one of those things that really makes it hard for us to change as we move forward. But it turns out, let's not be naive about it, system design is complicated. Inherently, that's true. When you're dealing with business, when you're dealing with very non-trivial applications, you have to deal with things that get really complicated. When you're dealing with business transactions, when you're dealing with medicine and various other things we have to deal with, you have to really deal with things that get complicated. But it turns out, unfortunately, though, we take what is complicated and we have sadly added complexity to what is complicated, and that becomes really, really hard. So what I want to really do is to take what is complicated and deal with it without adding complexity to it. So all I'm going to talk about in this particular presentation is my own experience, my own journey through organizations I've worked with for the past about 30 years, and what I've actually seen companies deal with almost every single day, and what is it that we can learn from some of those and maybe get better at it. So this is purely an experience road trip, if you will, about what I've actually seen out there. I'm going to start by saying that we are victims of our own complexity. We often want to tell, things are not really going well because of, and it's easy to point fingers. But I want for a minute to really point fingers at ourselves as developers. What have we done to make things really worse on ourselves? And I would say it's the complexity we create that makes it really hard for ourselves to deliver our results and make things work. So what really makes software system complex? I want to start with that question, where do complexity come from? And I'm going to identify maybe 6 or 7 things I would say are really making things very complex in this particular series of things we're going to talk about. The first thing is there are too many moving parts. And moving parts make really complicated things more complex. Now, we deal with this every single day of our work. We have to deal with things where there are several moving parts. And what happens when we have to deal with these moving parts? Well, Leslie Lamport once said, a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. And I think this is going to become even worse today with the world we are living in a distributed system we are living in, cloud computing we are living in, microservices we are living in. This is only going to get worse if we don't really know how to deal with these kinds of complexities. When it comes to this, what I've seen is things like excessive configuration. Unnecessary components, and too many layers. I'll give you some examples of these things I've actually seen. There was a client I was working with, and I looked at their code. I was doing code review, and my job was to review the code and maybe help them improve certain things. And as I was reviewing the code, I noticed that they had a lot of interfaces. And I love interfaces. I said, oh, this is great. They have all these interfaces. And then I saw them use factories, and I said to myself, I love factories. And I started reading the code a little bit more, and then after a while I noticed something really strange. They had 2 kinds of interfaces in their entire application. As I said, they have a lot of interfaces. The first kind of interface is where the interfaces had exactly 1 class implementing it. And the second kind of interface is where there were no classes implementing it. So I was like very curious. I went to the developers and said, I'm really sorry, I'm looking at your code, I need some help here. Why am I seeing interfaces that either have only 1 class, and then there are interfaces that have no classes at all? What's going on here? Their first answer was, Venkat, we want you to know the people who wrote that code don't work here anymore. This is one thing we hear always, isn't it? The minute you point to really bad code, they want to tell you, we didn't write it. Somebody else wrote it, they gave it to us, and we are suffering through it. And then I noticed that when I asked them why that exists, and they said, oh, these people sat out to write a framework, and they ran out of time, so they just left it like this and went away. And this is one fascination I see. I mean, why would you want to create an application when you could be creating frameworks, isn't it? And nobody wants to really get the work done. They want to create this framework because that's so cool to say. Imagine you're sitting in the conference, you're sitting next to somebody, and they look at you and say, what are you working on? How boring it is if you tell them, oh, I work on an application, I finish and I go home in the evening, it makes revenue for my company, and we just have a happy life. We don't do that. You look at the person next to you and say, what do you do? What do you do? And they will tell you, oh, I'm creating a framework. And then you're like, wow, tell me more about it. And they tell you it's got 30 million lines of code. And you're like, wow, that's big, isn't it? Oh, it's huge. What does it do? It causes ulcer for everybody. We can't deal with it. No. What does it do for a business? Oh, we haven't figured this out yet. And that's one of the things. It's so happy to tell us that we are dealing with monsters at work than creating solutions. The other experience I had was, this is even more shocking. I was working for a company, and this company they started about 15 years ago, and they were making I'll try to be as vague as possible so I don't really reveal the details about the company. They make a software for various different worldwide companies we know about. And when they started working on this business, they wanted to really respond to the needs of every single company they got contract to. And I'm not even kidding with you. I looked at their source code. In their source code, literally, you have code that says, if company is equal to ABC, do this. If company is equal to XYZ, do this. And there are custom logic they have implemented for every single company. And the way they managed this was to even go further, they had huge amount of configurations for it. And configurations like you could never believe it. And when I was working with these developers, they said, when a particular company signs up for a contract to buy their product, their team spends literally 6 months configuring their product to make it work. And the reason is because they want to make it extensible, they made every single thing configurable. Now, if you're going to make things configurable, the best way to make it configurable is using XML, isn't it? Well, they had XML configuration every single corner you could turn. And so if you want to really use their application, you just walk into this cave called XML file, and then eventually come out after a few months if you are still alive at that point. And this is like absolutely frustrating. They got to the point where, after 10 years, this company got to the point where they became slower and slower and slower to deliver the product because eventually it caught up to them. And they just simply could not survive in the business anymore. And their clients were like, you guys were really fast when we started working with you. Why are you so slow? You're not able to respond to change. Well, the very things they set out doing really made it really hard to them. So this is one thing that I've really clearly realized in my life is about XML. When we look at XML, we get excited in the beginning, but when we start using it, we learn a few things. And this is a philosophy of life I've really learned about XML, and that is, when it comes to XML configuration, XML is like human. It's really cute when it's small and gets very annoying as it gets bigger. And this is so true about XML configurations. We're not just able to deal with it in the long run, and that becomes incredibly difficult. So what are the things that really hurt us? Well, the applications become really brittle. It becomes very error-prone. It's really hard to deploy it, and it's very hard to reason. But one of the things I do as a developer oftentimes to look at a quality of design is I ask the question, how hard or how easy it is to test an application. If it's really hard to test an application, it usually is a reflection of a poor design, and that's going to really cost the business a lot more in the long run, and that's something I have to really do towards minimizing it. So the next thing I will talk about here is things that really make hard for us is what I want to call as invisible change. The reason I'm calling it as an invisible change is I've struggled with this for a long time, and more recently, I was able to put my finger on it. And I was working on an application where I spent maybe about 2 to 3 hours trying to figure out how a code somebody had written works. And I was very frustrated because it's costing me time, it's costing me money, and why am I not able to understand this? And that's when I was able to nail down to this one problem. Well, it turns out that I'm really frustrated about 2 kinds of code, and I hope you will agree with me. The first kind of code I don't like at all, and I get really frustrated, is the code that doesn't work. And I'm like looking at this code, I'm like asking the question, why wouldn't this code work? But even more frustrating for me is the code that works but shouldn't. And this is really hard to deal with. And you're looking at this code and saying, why does this work? It's not supposed to work. And then you're trying to really struggle to understand this code. And I remember this particular experience I had, and I could not really take it because I was so angry, is this was a piece of code I got from a developer, and they wanted me to take this code written in C++, and they wanted me to implement it using Scala. And I know C++ fairly well. I've been using C++ for about 30 years in my life. I've spent maybe 20 years of that time teaching C++ in college, and I've been working with C++ actively. So C++ is something that I kind of can code in my sleep. I know C++ fairly well. I've kept up with the development in C++. And after saying all of that, I started reading this code they had sent. And to be fair, it was not a lot of code. It was only a few hundred lines of code. And I'm reading this code and reading this code and reading this code, trying to understand what the code is doing. And if I understand the code, I can develop that in Scala for them. And after spending a lot of time, I was very frustrated, and I was not sure why the code was working. And I then started debugging, literally stepping through the code like I'm an idiot, and I cannot understand. And eventually I found out what was going on. I would initialize an object, and I would be walking through the debugger, and the object would have a certain state, and I would walk through a get method, and then suddenly I look at the debugger, and this object is absolutely populated. And I'm like, how could a small, innocent method end up populating an object so much when it shouldn't be really populating? And that's when I understood this idea of invisible changes. The developer who wrote the code completely tricked every other developer, including me, and they are making change to a state when you least expect it. And this is really unfair for a lot of developers because when they're reading code, they're dealing with a state of mind, and you want to make changes very obvious to the reader. You want to make it very transparent. And when the change is really invisible, it becomes incredibly difficult. Honestly, on this particular project, after struggling with this code for a long time, I realized that I don't have enough time to really work on it. And I finally emailed them and said, can you do me a favor? Is there a paper reference to your algorithm you have in this particular code? And they're like, sure. And they pointed me to a URL. I'm not even kidding with you. I threw the code away. I read the research paper, wrote the code in Scala, sent it to them and said, never talk to me again. I don't want to really deal with this kind of code because it's not a good use of my time. So what good is a piece of code if it really makes things invisible for you? So don't sneak around and change state in your application. You want the code to be really transparent because that's one of the complexities we often have to deal with. And really, the more invisible changes we make in the code, the less transparent we make in the code, it really becomes a direct impact on the time that it's going to take for developers to maintain this code. And time is a direct translation to what it costs a company and what it costs a business to really maintain that application as well. So it really has a very direct economic impact we have to be very careful with. The next thing I'll talk about here is about uncontrolled mutability. Now, mutability is something we all deal with oftentimes, especially in languages like Java. We do mutability quite a bit. Well, mutability is OK. What about sharing? Sharing is a good thing. But shared mutability often is really troublesome. I call it the devil's work. So it becomes really hard to deal with shared mutability. And we want to really be careful dealing with mutability. It turns out mutability needs company. It often hangs around with bugs and becomes really hard to maintain the code. And I'm going to go to the extent of saying that state transition causes brain damage. This is something we have to be very careful with because it becomes really hard for us to work with code where the code, as you're reading through it, goes through enormous mutability, and all the state transformation and state transition becomes really hard to comprehend. Now, this is only what programmers will understand, because what do we do every single day? You're sitting there and you're staring at code, trying to really, really understand what the code is doing. Now, only programmers will understand this because you are sitting there and intensely staring at a piece of code. You're trying to really understand how this code actually works. And as you're doing this, somebody just walks through the door and asks you this ridiculous question. And they ask you, have you had lunch? And what do you normally do? You kind of stare at them. You don't answer. And your hands are on the keyboard. You're staring at them. And they look at you and say, are you OK? And you're still staring at them. And then they say, you're weird, and they walk away. And they don't understand this. Because what they just did is this, right? When you're programming, you have built up all this state in your mind. And all this is in perfect balance right now. And you're just trying to connect how this object is talking to this object. And when they walk in and ask you, have you had lunch? This entire model just went flat on the ground. And the reason you're staring at them is you're thinking, look what you did. And now you have to put all this model back into your mind and try to get back to the state you were in. And that interruption is absolutely damaging. And only programmers understand this. In fact, I will tell you the best money that I ever paid in my life was when I went to watch the Social Network movie. And I was sitting next to my wife, and my wife always thought that I was weird. And this is something that I would say is wonderful in life, is to get married to somebody, and they kind of grow with you to understand how weirder you are than the time they met you. And to my wife's surprise, she didn't marry me. She actually married a programmer. And it took her a long time to figure this out. And our marriage got really better once she realized it. Because I remember way back in time, earlier during my marriage, there was one day she came to me and said, I need to go shopping. Do you want to come with me? And I said, oh, yes, I would definitely want to join you. I'll be with you in 5 minutes. And I saw her pick up the key and leave. And then I continued coding, and when she came back, I said, I'm really sorry that you left without me. I told you I'll be done in 5 minutes, and you didn't wait for me. And she came to me and said, Speedy, I love you, but you got to know this for me. When you say 5 minutes, in the real world, it's 7 hours. And that's when I understood that programmers have a different perception of time. When we say, remember what the boss tells us, right? Boss comes to you and says, how's it going? And you always say, I'm almost done. We always do this, right? We have a completely disrupted perception of time. But having said all of this, my wife was watching the movie with me, and right in the middle of the movie, she literally screamed, and she said, oh my gosh, I get it. And this is the scene in which she said it. I'll repeat this scene here for you. So here's a scene from The Social Network, and we'll see what's happening in this particular scene. I'll try to rewind this a little bit and play here. Sorry, give me a try to do this again. So let's go ahead and try this.
I didn't know we had a doorbell. Andrew, get the door. No, he's wired in. That's going to cut into security.
A little volume, please.
Andrew.
Calm down.
Good boy. I'm Sean Parker. Oh, he's wired in. That's what I'm talking about.
So that's what I'm talking about. Right there, she screamed and said, oh my gosh, I understand this. And when he said, don't talk to me as wired, and she said, now I know why you're weird like this. When you're programming, you're wired. And I'll tell you, the next week, I was sitting in the kitchen and programming. One of my kids came to me and asked a question. My wife immediately said, well, Daddy is here, but don't talk to him, he's wired. I'm like, yes, this is well worth the money paid for this movie. And for when people understand this, everything changes. I'm going to say happiness is when the world understands programmers. And the reason we are so weird is we have to load all this logic in our head and all this complexity to deal with every single day, and that becomes really hard for us to work with. The next thing I want to talk about here is lack of cohesion. Cohesion is where a piece of code is narrow, focused, and does one thing, and one thing really well. And when a code is not cohesive, it increases the complexity of the code to unmanageable levels. How many times have we seen methods that are so long that you don't even have a clue what it doesn't do? And that's a lack of cohesion. And we deal with this every single day in our work. So we want to really make the code cohesive. But why should we really do this? It really comes down to frequency of change. A code that is more cohesive has less frequency to change, and a smaller frequency to change, and a code that is less cohesive is going to change more frequently. So we want to really reduce the frequency of change of code. This reminds me of an experience. I was visiting a conference in Canada. It's a very unique conference because this is a conference run exclusively by students of Canadian universities. What is absolutely phenomenal about this conference is there is nobody else involved in organizing this conference, entirely done by students who are going to school in Canada. And they invite speakers, and they bring speakers from international destinations, and they host this conference every single year. One of the years that I had the opportunity to go visit them, they had a competition to build structures with purely Legos. And as I walked around the corridor, I was absolutely fascinated by so many different projects students have implemented. And one of the things I really noticed was that how small and modular and cohesive every single one of these pieces are, and yet there is almost an infinite number of structures we can actually create with it. A really interesting way to think about cohesion when it comes to these kinds of systems. The next thing I want to talk about is to really think about excessive dependencies. We have to deal with this every single day of our work. I remember this experience when I was visiting a project. They were doing a development in JavaScript. And one of the developers said to me that they stopped running automated tests because they couldn't keep up with the test anymore. And I said, what do you mean by that? Why are you not running your automated test? And he said, well, we upgraded a few of our dependencies, and some of the tests quit working, so we stopped running those tests. And without knowing much about their project, I asked the question, how many dependencies do you really have? And he said, oh, on this project, we have about 150 dependencies. I said, my goodness, on this project, 150 dependencies. And knowing that I'm not believing, he opens the build file and shows me, true enough, there are 150 dependencies in there. And I looked at him and said, well, why are you using all these dependencies? He kind of shrugged and said, because we found them. And this is so true, isn't it? And this is the plague of the Java world today. You are going to lunch, you're sitting and having lunch with your team, and you hear somebody in the next table talk about this new library in JavaScript called XYZ. And you turn to your team and say, have you heard this thing called XYZ? And everybody says no. At 3 o'clock, you really realize your build file has dependency to XYZ. Because, I mean, how could you not use a dependency you heard about at lunch, isn't it? This is crazy in the way that we are bringing dependencies into projects. And the more dependencies you bring in, the harder it becomes to really deal with it. And of course, I would say I've had one hell of a programming career, from DLL hell to jar hell through assembly hell down to NPM hell, and I always wonder what is next. But I'll talk about NPM for a minute. The other day I was on the flight, and everything was going well, and the pilot came on and said, the captain came on and said, hey, the flight is going really well, I'm turning off the seat belt, if you have to move around, please feel free to do. And I shouldn't have done this, but I opened my laptop, and all I did, honestly, was type npm install. Immediately turbulence, and the flight is shaking. And I'm like, I shut the laptop, I said sorry to the person next to me. And the captain comes on and says, sorry, folks, I'm turning on the light belt. And literally bad things can happen like this. And npm is one of those things. The other day I was talking to a developer, and he said, oh, I don't have to worry about it. I use Maven, and it takes care of everything. I had to deliver the bad news to him. Nobody uses Maven, Maven uses you. And this is something you have to keep in mind, right? So the point is that you have to really deal with these kind of dependencies. And dependencies can become really, really hard to work with as time goes on. And the more dependencies we have, the more unnecessary complexity we bring into applications. And that makes life really, really hard for us to deal with. So when it comes to this, one of the things we can do for ourselves to be better at what we do is to avoid the urge to bring in all these dependencies. So one of the things I follow in design is what's called the minimalistic design. How can I reduce the number of things I depend on? Because the fewer things I depend on, the better my life is as a developer. I'm not saying don't use any external libraries. That's not what I'm saying. What I'm saying is we are using way too much than we really need. And if we can minimize what we do, that will make our lives a lot easier and better. Dependencies are really hard to maintain. What is even worse is dependencies are really easy to introduce, but often really hard to remove. And they can become obsolete quite quickly. One of the things you have to deal with a lot of times is the more dependencies you have, the speed at which you can develop becomes the smallest, the slowest evolving one becomes your speed. How many times have you heard this? Somebody comes to you and says, oh, we are using Java 8, oh, we are using Java 9, or Java 10, whatever it is. And then you look at them and say, oh, we really wish we could do it. We are still in Java 7. And they look at you and say, like, why? Well, it's because everything we use is OK with Java 8 or 9, but this one library doesn't work with Java 8. We have to wait until those people upgrade it. The more dependencies you have, the slower you are to migrate to newer versions. And this is something I've noticed quite a bit. I started teaching Java 8 about 2.5 years ahead in Europe than in the US. And I kind of wondered, why is that? And eventually I found out a lot of my clients in Europe were using fewer dependencies, and they were able to upgrade much quicker. And a lot of my clients in the US had a lot more deeper dependencies, and they just could not move because the dependencies would hold them back. So the more dependencies we have, the harder it becomes incompatible and really hard to change as well. The other thing to keep in mind is, I think the right word to use is infatuation. And I call this the technology infatuation. And this is really dangerous. Developers are fascinated about newer, shiny tools and technologies. Again, don't get me wrong. I'm one of those people who love exploring things. I'm thirsty to learn. I'm thirsty to try out new ideas. But I want to, at the same time, clearly distinguish two things. My time I spend learning new things, and I would experiment on those on pet projects. I would create small projects. I would play with new technologies. But I would say you need to take the time to play with new toys and technologies, but have the wisdom of not bringing them into your projects until it really, really is needed. The worst way to learn a new technology is to introduce into a current project. You really need to play with it in isolation for a while before you make a decision to bring that on. Otherwise, what happens is we are bringing things on in more in infatuation mode than based on the need and necessity. So the question to ask is this technology the right choice for the current project? Are we going to be better off with it? What is the cost of using it? What's the cost of not using it? And I want to evaluate both of those. And one of the things I value a lot when it comes to technology is this one very important word I keep using when it comes to architecture and design, and that is reversibility. And I want to ask the question, how reversible is this decision moving forward? So what is reversibility? Reversibility is our ability to back out of decisions. If I decide to use a particular library today, and 3 months from now I say, that was not a really good choice, maybe I shouldn't have used that library, or maybe I should use something else, how easy or hard is it for me to change that decision? And that is really reversible. Certain things are easier to reverse, certain things are incredibly hard to reverse. An example of what is easy to reverse is maybe an XML parser that you decided to use, or a JSON parser you decided to use. Maybe tomorrow you decide to use a different parser. It's not going to cost you arm and leg. However, it depends on how we designed it. And for this, I use the term called surface area. So what is a surface area? So imagine this is the library that you are talking to, and if my dependency on the library is like this, my surface area is really small. I have a small code base that's talking to this library, and tomorrow I decide to replace this library. All I have to do is only affect that particular area of code. On the other hand, the same exact library, if I decide to depend on the library like this, I have introduced a bigger surface area. The day I decide to change this library is going to cost me more. So one of the things to consider when it comes to reversibility is minimize your surface area of dependency. When you minimize the surface area of a dependency, the day that you decide to replace the technology with something else, your cost of the change is minimum. So always ask the question, is it reversible, and can I reduce my surface area? The bigger the surface area, the more expensive it is, and the harder it is to reverse out of it. On the other hand, it also comes down to things that are really hard to reverse out. One of the things that's really hard to reverse out is languages. If you go to a team and say, throw away the language you are programming and use a different language, we'll get laughed at, because that's really, really hard to reverse out. Again, the dependency on the language is a bigger surface area. In a similar way, I will always ask the question about two different things. I said the reversibility is the ability to back out of design and architectural decisions. And I want to think about libraries and frameworks. Now, these two are very important. When you are trying to use a third party, look carefully at the words. Is it called a library, or is it called a framework? So what's a library? A library is what you use. What is a framework? A framework grows around you. And you don't call into a framework calls into you. And the minute you start using a framework, you get really logged into a framework. And I usually am okay with libraries. I am usually a lot more reluctant getting into frameworks, because frameworks are less reversible compared to libraries. So the use of a library is easier to reverse out of rather than a framework, which is really hard to reverse out. Here's my analogy of a library versus a framework. Using a library is like dating. Using a framework is like getting into a marriage. Don't take this too easily. And you can do dating and you can break off with less damage. But either getting into a marriage or buying a house and mortgage can be really expensive. So we have to really, that's another way to think about it. Maybe using a library is like renting a home, versus getting into a framework is like trying to purchase a home. That can be really expensive if you decide to change your decision. So when it comes to reversibility, I would rather depend on a library than a framework. And even with the library, I would rather reduce my surface area as much as I can. That way, I can think about reversibility. So one of the ways we can get out of the mess is to just ask the question, is it reversible? And this is one thing I do with my developers. I always ask them to put a number on, how is your decision reversible? Is it easy to reverse? Is it hard to reverse? If it's easy to reverse, and we can prove that it's easy to reverse, I would move forward more easily. If it's really hard to reverse, I would ask them to take a little bit more time in committing to this decision, because that extra time we spend in deciding can save us a lot of grief in the later time. So I want to make sure the intensity of my decision, the effort I put in, is in proportion to the reverse of reversibility in general, or proportion to the reversibility in general. So when it comes to this, I'll talk about something that I faced in my early part of my career. I've been programming for about 30 years now, and when I was a young developer, we lived in a very different world. I'm not trying to tell you that the world was better then. I'm just making an observation, not a comparison. When I was young, when I wanted to use a library or a tool, we didn't have internet. This is always fascinating. My children would come to me and ask the question, what do you mean there was no internet when you were a kid? They just cannot understand this idea that there was a time when we didn't have the internet like we do today. And there was no internet, there was no browsers when I was a young developer. And you couldn't just go Google for things, there was no Google. And you read about a product in the trade magazine, and then you go to the boss and say, I want to purchase that product. And then you get approval, and then you get more approval, and you go through this procurement department, and eventually they'll come to you and say, we have approved your purchase, you can purchase it now. And then when you place an order, eventually one day, this will arrive at your desk. And then you take this tape drive, I'm not even kidding with you, you would take this tape drive and you insert the tape drive into the tape reader, and then you start installing the product using the tape drive. When there's a tape drive involved between you and the product you want to use, you don't use that many dependencies. So we had fewer dependencies on our product back then, and usually I was the one who had to do this tape drive business. I had no interest in doing it. Well, today we live in a very different world. If somebody tells you about a particular library, you click on one button, and before you could blink your eyes, that's integrated, downloaded, integrated into your product. And the next thing you know, your dependency hierarchy is so big. And what I'm trying to say is that when it was really hard to install, we had fewer dependencies. Now that's really easy to install, it's rampant with dependencies on our product. And this can be a really dangerous situation to be in. And this leads to what I would like to call as resume-driven development. The other day, I was talking to a developer, and he said he's going to use one particular library. And I looked at him and said, I'm really sorry, I don't understand. I know what your product is doing. I can't understand why you would need this library on this product. And he looked at me quietly, looked around, and then he came close to me and said, I want to ask you a favor, Venkat. I said, what is it? He said, do me a favor, don't talk about this to my boss. And I said, why not? He said, because I convinced my boss we need this library. And I don't want you to tell him that we don't need this because I'll be in trouble. And I asked him, why do you want to use it? He said, because I want to put it on my resume. I want to tell people that I know this particular tool. This is a really wrong thing to do. I see this quite often. The minute I look at a resume, I look at all the tools and libraries and languages they have used. And I look at all this and say, wow, 200 libraries you know. And I'm thinking, are you going to come and use all of that on my product? I would never succeed if I do. So I don't want that to be a list of product tools available in the industry on the resume. That is a very dangerous precedence to have. I'll share with you a very sad story here. I call this a tale of infatuation. I'm saying this with a broken heart because we want to work on projects where we succeed, but unfortunately that doesn't happen all the time. So this was a time a decade ago or more, and this was a time in the US when we had the deepest of recession. People didn't have jobs, the unemployment rate was really high, and everyone who's holding on to a job is really happy that we have jobs. And I was working on a project. I was so happy to be on this particular project. I was a consultant. And we wanted to hire people to work on this particular project. It was a fairly small company, really good group of people. We had a really good communication. And I was working with this team. And one of the things we wanted to do was to hire an extra developer to help us on the project. It turns out when the economy is bad is also when it's really hard to find really good developers. We were interviewing people almost every day. And one person we interviewed, honestly, I was blown away by this person. This person was demoing a framework he had created. I was in the interview, he was doing the demo, I was watching this, and I was absolutely fascinated by this guy's knowledge. My boss at the time came to me, who was a VP of R&D, and he came to me and said, "Hey, Venkat, what do you think of this guy?" And I said, "Don't waste your time talking to me. This is the best guy I've ever seen. I'm very selfish. I want to learn from him. I want to work with him. And if I work with him, I will learn everything he knows. I'm really, really selfish for that reason. Don't waste your time. Go hire him." And my boss said, yeah, that's fine. But tell me, what do you think of the framework he's been developing? I said, "That's the best framework I've ever seen. I've never seen anything as wonderful as that. Don't waste your time again. Go hire him." And then he said, yeah, but one last question. What do you think of us using the framework? I said, "Please sit down here. Let me talk to you. Do not ever talk about using the framework. We got a very busy schedule with us. We're going to release this product in 6 months. We're working really hard on it. I don't want you to even think about using the framework. Hire the guy, put him to work. Let's get this product released. That should be our focus. And don't even mention about using his framework." Well, 2 weeks went by. I was busy coding. This was a Wednesday afternoon. And when my boss comes to me, comes over, sits on my desk and says, "Venkat, I got a great news for you." I said, "What is it?" "Well, we have hired this guy. He has accepted to join us, and he's going to start next week." I said, "I cannot tell you how happy I am. We're going to have a really good time here. This is going to be amazing." And then he said, "Oh, by the way, as part of the hiring contract, we decided to use his framework." I said, "You are joking, right?" He said, No, it's committed. It's been signed as a contract. We're going to use his framework." I said, "Well, if that's a decision that's been made, I just turned in my resignation right now." He said, "Oh, I know you're going to say this. You're so predictable." I said, "I'm so glad I'm predictable. Do me a favor. If you have any other project, call me. I want to come and work with you guys for that. But on this project, I don't want to be a stumbling block. I don't want to come to work every day and say that you are wrong." And this is something I care about a lot. I don't want people to agree, but I want people to be aligned. If you cannot be aligned with what you're doing, the best solution is to leave. You want the people to do what they want to do. Don't be the stumbling block on that. So I went home that evening, fired myself from the job, and this is one of the very few days I ever showed up home, on time or even ahead of time. My wife was very surprised seeing me walk into the house. She said, "You're early today." I said, "I quit." And she said, "What do you mean you quit?" I said, "I don't have a job." And she said, "Well, in that case, I got some dishes for you in the kitchen to do." That's how she is. And so I was without job for a couple of weeks, found something else, and moved on. And when I left, of course, we had 6 months to finish this project and release it. And a full year went by, year and a half went by. 18 months later, I was at my desk doing some work. I got this call. I said, "Hello." And he said, "Hey, Venkat." I'm like, "Hey, how's it going?" He said, "Go ahead and say it." I said, "I'm sorry, what do you mean go ahead and say it?" He said, "Go ahead and say it, told you so." I'm like, "Oh my gosh, what happened?" "Well, we have been developing this product for 18 months now, and we haven't finished it, and we've been putting more and more code to make the framework do what we want." Remember, we didn't have the need for the framework in the first place. And they've been working on building this framework so it can actually serve the needs of the project. I said, "I'm really sorry to hear it. What can I do for you?" And he said, "I was wondering if you can come and help us to move the project and turn it around." I said, "I'm really sorry. This is the reason I quit 18 months ago, because I know you're getting there. So there's no way I'm going to come now." 6 months later, this is 2 years after I quit, I got the phone call again, and he said, "I know you don't want to work with us. That's fine. But here's a gig for you. We'll pay you for a day. You come over, look at what we have done, write a report, and you can leave." I said, "Oh, the project is done." He said, "Oh, yeah, it's completed." "Oh, I'll be more than happy to. I'll come and do a review and write a report and get paid for it." And I went there. I'm not kidding. I went there at 8 in the morning. And I opened this application. I'm in this room alone with him. And I enter a little user ID and password, did a search, and I click on the button. 25 seconds later, a window popped up. And I'm looking at this, I'm like, whoa. And I try this again, I'm timing it, and I'm profiling it. And 25 seconds later, the window popped up. And I said, hey, it took 25 seconds. He bites his lip and says, uh-huh. I said, the database, don't talk about it. Here it is local, in production it won't. I said, machine speed, don't talk about it. This is much faster than what will be in production. And then I said, I profiled it. That one click created 1,852 objects. He said, yeah, it's object-oriented. And I am looking at this and saying, hey, question for you. Where is everybody? And he just kind of kept quiet. I said, tell me, where is everybody? He said, the president of the company fired the entire team last week. Because this performance is so poor, he fired them all. And then I looked at him and said, I think you didn't call me to write a report. What do you want me to do? He said, fix it. I'm like, I'm a mortal human being. I can't do this for you. And I was there till 10:30 that night. He wouldn't leave me. And when I left, I said, I'm going to leave now. I have only one final request for you. Never call me again. And I never sent an invoice for the day. I never got paid because I told him, I don't do postmortems. Sorry. And that is one of the problems is when you see people make really bad decisions and face the consequence, it really hurts my feeling because here is something you can actually do well and get infatuated and suffer. So don't build what you can download, but more important, don't download what you really don't need. So the one thing I want to keep emphasizing over and over is the word need. Do we really, really, really need this? If I don't need something, that's a liability by bringing on a dependency into my product, and I want to really resist that as much as I can. The next thing I want to talk about here is accidental complexity. So what is accidental complexity? Accidental complexity is every single application we work on contains two kinds of complexities, inherent complexity and accidental complexity. Inherent complexity comes from the problem domain. You cannot remove it. But accidental complexity comes from the solution domain. And the solution we create brings in complexity, and to solve it, you bring other solutions, which in turn increases complexity, and then makes life really, really hard. So we look at a problem, for example, and say, we can solve this problem using a pool of threads. Now we end up having a pool of problems. And I'm going to say that concurrency is a great example of accidental complexity. And I've seen this over and over and over in my experience. A good example of this is Brian Gates' book, The Programming Concurrency in Practice. Before I read this book, I used to think that no programmer can get concurrency correct. After reading this book, I know no programmer can get concurrency correct. It is that complex. It's really, really hard to do and to be able to stay sane after doing it. Here's an example of it just to entertain this thought for a minute. If you notice over here, I've got a Boolean variable called done, which is just uninitialized, which I initialize right here in the main. Then I start a thread of execution. It says running. And then you can see that I have a count is equal to 0. And then if I say, while not done, I'm incrementing the count here. And eventually, when the done is true, I will exit the while loop and print exiting thread. Then if I come in here, I wait for 2 seconds, and then I say setting done to true, and I set done to true. So logically speaking, done is false in the beginning, done is true in the end, and this thread is running until done is true and exits the loop at that point. So everything seems really logical, really reasonable. If I go back and run this little piece of code right now on the command prompt, you will notice that it starts the code, it's running. 2 seconds later, it says setting done to true, but unfortunately, it never completes. Well, what's going on over here? The reason it's going on over here is that this thread is never exiting. Why is it not exiting the loop? And that's because the compiler says done is false and optimizes it. What is really hard with this problem is that the amount of changes that can make the behavior of the code different. To make things really worse, you can use this as an interview question, actually. I'm going to say thread.sleep, but I'm going to put a 0 to add insult to injury. And I'm going to say catch exception EX. If you notice over here, this is a thread that is sleeping for 0 amount of time. So literally, I put a sleep which doesn't do anything. But the sad part of this code is when I run the code now with this particular, it does require you to type properly here. So if I try to run this code with a sleep of 0, what does the code really do at this point? And surprisingly notice the code is exiting when you add this. So what is really happening? Well, one of the problems is there is no point in learning about concurrency in Java without learning about the Java memory model. And I call this one as the Horcrux. Imagine how boring Harry Potter would have been if in the beginning of the movie they gave you a list of Horcrux and where they are located. Nobody would watch the movie, isn't it? What made Harry Potter so excellent was you didn't know there were Horcrux in the beginning. And then you came to know there were Horcrux, but you don't know where they are and what they looked. And you spent all this time with Potter finding with his friends all the Horcrux and destroying it. Well, Java has 7 Horcrux as well. And these Horcrux help you to cross the memory barrier. And sleep is one of them. Volatile is another one of them. And then synchronized is one, and so on. And what makes really concurrency really hard to program is these Horcrux we keep discovering, and we have to really learn about it. So a key design skill we need to develop is the ability to discern accidental complexity from inherent complexity, and that is absolutely critical for us to become better developers, is to understand what is inherent complexity, what is accidental, and find ways to remove the accidental complexities. The another thing is imperative style of programming. I'm going to make the claim that imperative style is accidental complexity. And this is so true for a lot of things we do, is we get really dragged down into this problem quite a bit. Let's look at one example really quickly to understand this. Here's an example of this code. I have to compute the total of the square root of the first k prime numbers starting with n. Let's think about it. How do we really do this? How do we find the total of the square root of the prime numbers? Let's do this in the very familiar imperative style of programming. So what am I going to do? I'm going to say over here, double result is equal to 0, and I want to output the result when I am done. Then I say int index is equal to n, the starting number. Then I say int count is equal to 0. Then what is it I do? What did I do until this point? Absolutely nothing useful, isn't it? All I did was I created a bunch of variables. In fact, here is a sign why this is useless. When you program normally, you don't give such beautiful names for it. You call names like T and F. You convey your intent. You say you don't deserve to live. That's how we communicate to variables how we feel about them. And then what do? Then you say while count is less than k, and at this point, you come to a grinding halt, and you ask this nerve-wracking question. Is it less than or equal to? Do you ever ask this question? Every single day, isn't it? And then you ask the question, is it less than or equal to? Then what do? Then you say if is prime of this value index, if it is a prime number, then I say over here, result plus equal to math dot square root of that number, and then you execute this code. I'm going to ask you the question, is this code correct? And you would probably look at me and say, no, it's not. Why not? Because you got to increment the count. I'm going to ask the question, is it correct now? And you're going to say, no, you got to increment the index. Is it correct now? You're like, no, it should be outside. How vexing is this? One has to be inside, one has to be outside. This is an example of accidental complexity. I'm going to ask you the question now, is this code correct? And at this point, you are thinking, wait, let me read the code, let me figure it out. And I tell you one thing I've learned in my experience. Programmers are the smartest people on earth. Because when you show code like this and ask them, is it correct? They will give you a very tactful answer. They will say, it looks good. Because they never want to say it is correct. And I'm going to run this code this time and see what it does. And it is going to give me some kind of an answer. Or in this case, I need to return the result. So I will do that. So return the result. And of course, when I run this code, we can see some result it is producing. That's an example of accidental complexity. Let's try this one more time in the functional style and see how this is going to look like. So I'm going to say return stream. And I'm going to start with the stream right here. Dot iterate. Start with the number n, given a value, give me a value plus 1, and then I'm going to call a filter, and given an element, only give me the prime numbers, if you will. Then I will perform a map to double, and I will ask it to perform a square root operation, and finally I'll call a sum, but I only want k numbers, so limit k. It's not k plus 1, it's not k minus 1, just the value k, I can run it. And when you look at it, the code becomes a lot less complex because you're not dancing around. You're not trying to figure out all this juggling between properties and variables and values. The code begins to read like the problem statement. Given number starting with n, give me all the prime numbers, give me only the square root of the prime numbers, give me k of them, and total it, and life becomes very easy. Well, that is one of the things. Imperative style is packed with accidental complexity, and one way we can remove the complexity is to be more declarative as much as we can. A declarative helps us to keep the focus on the problem instead of on the solution, because the solution leads to accidental complexity. The problem is inherent complexity we want to deal with. The last thing I want to talk about here is called entwinement. And this is something we all get dragged into in our lives. So if you take an example of entwinement, in Java, we have automatic garbage collection. Well, good news, we have automatic garbage collection. Bad news, it's not deterministic. We don't know when the garbage collection will happen. In fact, in more recent version of Java, Java 9 and later, the finalize has been deprecated. We cannot use it, or we shouldn't use it. So what is wrong with this? The problem is, if you want to clean up external resources, where do you clean them up? The wrong approach was to put it in finalize. And this is called entwinement. In fact, Richicke has a name for it. He coined this term. He called it complecting. Complecting is where you take completely two disjoint ideas and you put them together when they don't belong together. Memory management and resource management are different. You have automatic garbage collection for memory management. You don't have anything for resource management. Trying to mix them together is a terrible idea, and Java took a wrong turn doing this. So complecting things is a source of complexity, Richicke says. This is basically taking two different things and bringing them together is really a terrible idea. Go back and look at your own applications. Where do you bring two things that don't belong together, and how much it costs in the long run to deal with it over time? So we talked about a few things here. We talked about where complexity comes from and how to deal with it. We talked about too many moving parts. We talked about invisible changes in applications, uncontrolled mutability, a lack of cohesion, excessive dependencies, infatuation to technology, low-level use of concurrency models, imperative style of programming is another complexity, and finally we talked about entwinement. These are purely things I've observed in my own experience on projects I worked with for clients, and this is purely a gathering of things that I've been exposed to. I'm sure you would probably add to this list based on your own experience, things you may have already seen, and things to avoid in your own experience as well. Well, we should learn to deal with complexity, and we should have the wisdom to minimize it. And this is a professional responsibility of every one of us as developers. This is not something we can blame others for because we work actively to either build complexity or we work actively to reduce it. It's our professional responsibility in our field to do it. So we should learn to deal with complexity and have the wisdom to minimize it. And why is that? And the reason I would say is a maintainable code is a gift we give for ourselves for the future. And we will be very thankful, not only us, but people who come later on the project will be really thankful for that. And we want to really develop this maintainable code as much as we can. And that's our responsibility as well. Hope that was useful. Thank you so much for coming.